Every time you talk to ChatGPT, Claude, or any AI assistant, it starts from absolute zero. It forgets your name, it forgets what you told it yesterday, it forgets everything. But right now, behind the scenes, there is a massive scientific war happening between the world's top AI research labs to solve this exact problem. And what one team just discovered is about to change how every AI on Earth works. Stay till the end, because finding number 2 completely broke my brain. Here's the dirty secret about AI memory today. It's basically just search. You say something, the AI searches your old chat history, and whatever pops up first, that's your memory. People test these systems and say things like, oh, Mem0 scored 21, Zep scored 84, and then they stop. Nobody asks why. Nobody asks where the bottleneck is. Is it how memories are stored? How they're retrieved? How they're updated? The entire evaluation framework is stuck in the last decade. A new paper from the Open Databox team said, stop. They broke every memory system in existence into 4 modules. R, how memories are stored. Flat text, knowledge graphs, composite, even multiple engines at once. S, how raw conversations get turned into memories. Do you just glue the lines together? Extract facts? Parse into knowledge triplets? Q, how you find what you need when a question comes in. Attention, vector search, graph walking, hybrid. And U, how memory is maintained over time. Append with timestamps, FIFO eviction. LLM merges, offline fine-tuning. They wrote this as MSys equals RSQU. And then they benchmarked each module independently. 12 systems, 5 workloads, with real cost metrics. Suddenly you can see exactly where each system cracks. Finding number 1. This was my biggest aha moment from the entire paper. Memory retrieval is not a ranking problem, it's an evidence assembly problem. Here's what that means. Simple Mem gets a recall at 1 of 39. That means on the very first hit, it pulls out the one obviously important line. Phenomenal, right? But the moment you widen the search to recall at 5 or recall at 10, or the moment the evidence is buried deeper in history, Simple Mem falls apart. Meanwhile, AMEM and MemTree blow it out of the water, scoring 69.5 and 59.7 at wider budgets. The hard part isn't finding the first relevant thing. The hard part is gathering the complete scattered set of memories you need to answer a question. And that's where explicit structure, links, and hierarchy pay for themselves. Flat similarity search is a short-range weapon, period. Finding number 2. This one flips the entire graph versus vector database debate on its head. Structure does not drive cost, maintenance scope does. People assume that structured memory, like knowledge graphs, is expensive because it's structured. The data says the opposite. It's expensive when every write propagates globally across the entire system. Lightmem and MemTree stay dirt cheap because their writes are local. A new fact only touches its own subtree. But Cogni and Zep, 116 seconds and 155 seconds per operation, because every single write triggers a whole graph consolidation. Structure is totally fine. Global recomputation is the enemy. Finding number 3. This is the most counterintuitive result in the entire paper, and it goes against everything the AI industry is doing right now. Late filtering destroys fine memorization. Let me say that again. Fast memorize, which preserves raw conversation lines, scores 25.5 on exact match. Fine memorize, which distills everything into clean structured facts, scores 2.5. That's a 10x difference. Raw lines beat summaries on all 4 metrics. Why? Because aggressive extraction throws away the connective tissue that makes multi-hop reasoning possible later. At write time, you do not know which detail will matter in combination with something else in the future. So preserve now, filter later. That's the principle. And one more thing. The current AI building obsession is putting reflection and rethink loops everywhere. Well, for memory systems at least, the data says reflection adds cost with 0 gain. Planning plus reflect actually performed worse than planning only. Once the retrieval route is planned, extra deliberation weakens the decision. Stop overthinking your memory. Now here's the money chart. The researchers plotted utility versus latency for all 12 systems. The Pareto front runs from Lightmem at 4 seconds, through MemTree at 16 seconds, AMEM at 18 seconds, to MemoryOS at 29 seconds. Then there's a massive cliff. Cogni and Zep give you the last few utility points, but they cost 116 and 155 seconds. That's 4 to 10x more for marginal gains. The message is clear. Pick your point on the curve based on how latency sensitive your app is. The highest quality isn't always worth it. So here are the 3 principles every AI builder needs to burn into their brain. 1. Preserve raw data now, filter later. Don't distill your memories into clean facts. You'll lose the connective tissue you need for reasoning. 2. Keep writes local. Structure is cheap. Global recomputation is what kills you. 3. Skip the reflection loops on memory retrieval. Plan the route and execute. The extra thinking literally makes it worse. If you're building AI agents right now and you're not thinking about memory architecture this way, you're already behind. Link to the full paper is in the description. Subscribe for more deep dives like this.